This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe Think Tank.
The Fringe Think Tank it is then. Now let's give them back their destiny and open it up to the world.
Hello everyone, welcome to the Fringe Think Tank. My name is Nathan, otherwise known as Old Man Builds. We have the benefactor here, and Gerald will be joining us shortly. What's going on, Ben?
What's up, Nathan? Don't be frightened. That's my second computer logged in here because I have some videos on that computer. We didn't get hacked or nothing.
No, we're good, man.
Okay, yeah. So I had to log into this from my second computer because I do have some interesting updates for you guys about my research with the rodent coil.
Right on, man. Share away.
All right, give me a second. So first off, I'd like to say, while I find this, that this research has definitely been a roller coaster. So there have been a lot of ups and downs, specifically because I'm learning. This is a learning process for me. I don't have a background in this. I did some tinkering as a kid, but, I don't have a professional background in electrical engineering or anything. I kind of took on the responsibility without any qualification. So in that respect, I did make some mistakes, specifically while measuring the current in my original 0-point energy solved question mark video. But suffice it to say, we finally have some positive results regarding potential over unity in the system. Nice. And so it was a very newbie mistake. I hooked up the multimeter wrong to measure the current in my original video. Now we did find some old live streams of Daniel Nunes. And they're very long, and he goes over in extensive detail how to hook up his coils and configurations. And keep in mind, we're not exactly using his exact coil configuration. We're not using his frame. I'm using somebody else's frame, and Michael's using what he thinks is the best replication of Daniel's frame, because we don't have all that information. It's gone. Now, I watched some of his videos and talked to Michael. And Michael did point this out to me, but he did converse with me in trying to figure out how we are going to measure the current. And we did figure out a way to measure the current from the transistor in the Joule Thief circuit. And going over some old footage, we did confirm that we're measuring it the right way by Daniel himself. So we are getting some really positive results. I'm not going to verify anything at this point because we want another independent check on this. So at this time, Michael is in the process of printing out the exact frame and size, along with getting the exact gauge for the Mark I that I'm using for these experiments. I'm going to pull up some of the results, but and I have a couple of videos to show you guys, but right now I wouldn't get too excited, because the energy that's going into the coil and that's compared to the energy that's coming out seems to be a lot less, but it's not translating into usable energy at the moment because we haven't figured out how to align the capacitance correctly with the load. So with these systems, what I found out is you have to have the correct capacitance and you have to have the correct kind of load attached, because the whole circuit, the load in the circuit and the coil, they're all resonating together. It's humming, you know, and that's why it makes that humming noise. So we're all on the right track. Michael got a lot of ozone production out of his configuration, the same configuration I'm using, which is a very good sign, because ozone, as you know, doesn't really happen at low voltage. It takes like at least, I think, 4,000, and in some cases maybe 1,000 volts. But it was spraying out like mad, and it was at 43 watts. 43 watts. And it filled his whole room.
It'd be awesome to have him turn off the lights and see if you can't get a picture of the actual plasma breakout. That'd be awesome.
Yeah, I got to ask him about that. We're going to have another session soon, and we got a lot to go over because, you know, he's in a different time zone. So we got to, you know, align our research somehow. And we take the time and go through each other's, you know, discoveries or test results and all that, and compare and contrast. But we're really getting close. These are really positive results. I'm going to load up the screenshot that I sent Nathan earlier. Just some of the preliminary results that I took earlier today. Give me 1 second. Where is it? Oh, there we go. Okay. Now, we did find out, and this is the most interesting thing here that I found out, that Daniel Nunes claimed that he actually didn't get, I don't think he actually got, at least when he was talking in one of his interviews with a PhD engineer who was trying to check his work on over unity, basically. And he was like really impressed. And he was like, you know, he's got his coil and he's walking him through it. And he basically said, well, I never really got over unity with the Joule Thief. That was more of efficiency outside of a grid platform. He got over unity with the stereo amp receiver in a true AC sine wave, he said, which is interesting. So the fact that we're getting these results right now is an indicator that we might have something that Daniel didn't, which is very exciting. I mean, we're already... Cool. Yeah, I've already documented, and this is undebatable at this point. The video that I just put out with the yellow neon, that doesn't excite. The breakdown voltage doesn't excite until 120 volts DC. Right? It doesn't light up unless at least I think the minimum might be 110. It might start to excite, but still you need what? And I was putting in 5.5 volts. That's way times 10. That's way more than 10 times. That's like 20, 21 times, something like that. So it's very exciting that we're getting these kinds of results with the system. Okay, so here, what I did from the circuit video that I'm about to put out, I'm sorry I haven't put out yet. I've got, 1,000 things on my plate, but I will put out Michael's circuit video for the Joule Thief very soon, I promise. But something that was different that I did from his setup in the Joule Thief, the excitation circuit, was instead of hooking up instead of hooking up the start of channel A to the end of channel B, I hooked up the end of channel A to the start of channel B. And here is the first one where I have the original, and then the second, or the first one where I have that set up, right? And then the second one, I took the outputs that were left and I switched them, the positive and then the negative, I switched them that are going into the transistor. So here's the difference. The input voltage on the modified method, Michael's modified method, with the switching of the start and end connections, I had 9.8 volts going in, and the current from the power supply was 0.33 amps. Now that gives you a roughly 3.2 watts input. Now the output voltage I was monitoring with the oscilloscope because my equipment on the multimeters aren't accurate enough to pick up the voltage. They just aren't. Their true RMS is like evening out the symbol. It's not a signal. It's not picking up the spikes or something. So I have to put the oscilloscope and see the true signal, and you can see the spikes. And when you monitor the spikes, you get roughly, and I have to approximate because the oscilloscope is kind of cheap, but you get roughly 90 volts. And we can confirm this by the lighting of the neons, right? They're not going to light below that breakdown voltage, remember? So when monitoring the output current, I'm hooking the positive right up to the transistor, okay? The collector. I'm hooking the positive of the multimeter to the collector of the transistor, and then I'm hooking the negative right up to the output, the positive output of the coil, right? So it's just in between the output of the coil and connected to the collector of the transistor. And we get with that 0.21 amps, okay? And it's a little tiny bit of a loss, but that's incredible. Okay, that's if you do the math, that's 18.9 watts on that output there. Again, we haven't been able to match the capacitance and the load with the system yet to effectively use that. But that's there, right there, objectively. And we don't know exactly what it means at this point. It might be an anomaly with my system, but we're going to try like heck to replicate this. Okay, and so you can see in the last column, I have the current going through the coil and compared to the current coming out of the coil. Now, this is not connected to the transistor. So this measurement is just so I take the positive of the multimeter, take it off the transistor, and just clip it right in between the output of the coil and the transistor jumper. So that gives us a 0.29 on the amperage. So instead of hooking it up to the transistor, we're just hooking it up before the transistor. We're hooking it up to see exactly how much current's coming out of that coil before it hits the circuit. So that comparison is pretty relevant because that tells us, okay, this transistor is actually using a little bit of amperage, which it's supposed to do. But this is damn near close to input amperage. And you can see the bottom column is the twisted method where I take the two outputs and I twist them or I flip them, and you get at 4.5 watts on the output compared to 1.2 watts on the input. So it's pretty incredible. We don't know exactly what it means yet, but I'm very optimistic that we have something significant here.
Can you zoom that back in, Ben?
Oh yeah, 1 second.
Well, I just want to look at a few numbers there. So your output current is 0.21 amps, and your end, you said it was 0.32 amps?
No, yeah, the input, 0.32. That's from the workbench power supply reading.
Okay. So if we take that away, you basically got 0.33 amps going in, 0.21 coming out. So you swap some amps for volts is what looks like happened, but then you multiply the voltage as well.
Something like that, yeah. Something like that's going on.
So that's hold on. Yeah, 0.33 and then 0.21. So you had a bit of an amperage drop, which I would imagine you would over that distance.
Yeah.
Then you gain the voltage enough to turn on the neon, right? So you got the 90.
Mm-hmm.
Yeah. You multiplied some voltage and you converted a few amps. That's awesome.
And and honestly, that's actually what we're looking for is a little bit of loss on the amperage for the output. You know, it's not going to be what I saw originally when I had the screw up. It was like more on the output for the amperage. I don't think that's going to happen. And that's not what I've seen with everybody who's replicated Daniel Nunes's research either. They've had a little bit less on the output. Like you said, they're sacrificing a little bit of amperage and then multiplying that voltage. I think that's a good way of explaining it.
Yeah. I mean, you got it, Ben. Right there. You definitely got it. Definitely in the right direction. That's for sure.
Yeah. We're very close, Nathan. We're very close now.
Use that voltage to propel, right? And then you capture it because that's how you create your amps.
What's going on, Gerald? It's good to have
you
with
us. Not much. How are you guys?
Hey, Gerald.
Sorry I'm late. It's been a crazy freaking weekend.
Yeah.
Looks like I gotta adjust my well, maybe not. So yeah, I have to apologize to the audience. Didn't get too much done as far as experiments to show off. I was doing some high voltage experiments, some crazy stuff out at my friends in the country. I might know what the problem was that you and I were discussing about distance.
Yeah.
Has to do with height.
Yes. But it also has to do with the material.
Yeah. No, I get that. But your height's going to give you more of a distance in that same material.
So
think of a pyramid, right? A pyramid brings the height of your ground line up so far, and it extends as it's starting to fall because it falls off exponentially, right? I can't remember what the calculation is, but so it should be like strong, a little bit weak, none. Almost like a house wall, right? So your peak and then comes down and cuts off. I don't know.
So
from my test, that's what I'm seeing.
I don't disagree with that because we talked about the height of the obelisk and stuff like that, and we had that same discussion. Remember?
Right. I was doing some tests just on Sunday for that very same reason, and I'm finding that height matters.
Silica, the sand itself, matters.
Yes, that does.
So just basically what we're looking at, guys, I made a 10 foot by 10 foot. You can call it a pond if you want, like a little damp lake, like a little bayou place. But we're trying to light up the whole thing, and we're going through possible ways to do it. And if that little mud test that I did will amplify into something bigger is what we're looking for. So we're looking at all possible things that could have been in there. We know that we had it in a glass container. We know that there was mud. We also know which way we connected our coil. So which parts are going to make it function is basically what we're talking about here. So we identified that there's glass. So glass is basically sand or silica. And there was 80% in the container that I used. So with that being the case, I have mud only. It might be beneficial to put sand in there and still have it damp, which is not a bad thing. But then the height matters. When we set up our coil, I had it right on the ground, and it wasn't going very far. And then Gerald just said to pick it up, put it up higher. The other problem I had was I didn't double ground it. So I was using my Slayer Cider circuit instead of my ZVS circuit, and it's just better to ground the ZVS, but I wasn't making the ground the capacitor, so I wasn't getting the distance I wanted. So I didn't ground it, and when I didn't ground it, okay, just understand this, it lit up better outside the pond than it did inside the pond. And the reason is there was heat in the ground still outside the pond on a very cold morning versus the inside. So I didn't take temperature into consideration, even though we talked about it a ton. I didn't do it, and I was not creating the correct temperature difference between it in order to pull the power.
Oh, that's how you learn.
Because my ambient temperature in my garage is about 70. The temperature outside that day was closer to 30 degrees. So
sometimes you just don't consider those variables, until.
But they count because those variables they're important. But then they shouldn't. Well, that's interesting. See, the way that I have been seeing it, and I don't know if I'm doing something a little different than you, or I don't know. I'm still working on things. I don't want to let out too much right now because I'm seeing something I'm not sure of. I want to run by you later. But it has to do with the two electrodes, right? Have you ever seen high voltage where they make that glass. They put high voltage into the glass and then they hit it with a hammer and it spreads out. It makes that beautiful pattern.
Absolutely.
That pattern is what you're going to see between the two electrodes fractally in your soil. But it has to be created first, so the conditions have to be right in the beginning. But I think if the conditions in your soil were right in the beginning, after it's been conditioned, then you wouldn't have an issue. You'd be able to go outside or inside of that water pond, or what you were saying. It wouldn't matter, because like Wizard of Woodstock said, it's like an electret at that point. You know what I mean?
Mm-hmm.
And then once it's been all set up and it's running, and you see, this is one of the things that Tesla did in his experiments. A lot of people don't either consider or go back into his notes for. When he started doing the ground experiments, he started close together and then was moving them apart, right? So he was building that electret, whether he knew it or not, till he got to a distance where it was like, hey, check this out. And then he put out 100 light bulbs. Now, don't get me wrong, there was a little more to it than that. But generally, that's kind of, from my understanding, where it's at. And that's why he went so high up on the Wardenclyffe Tower. Because from my understanding, it was something like, was it 1,200 feet tall or something? 10 stories or 9 stories? It was tall, right? It was like a radio antenna. Right?
So I basically need to create a stand in the center of it. Put the Tesla coil right there.
No, your two electrodes, like your wire, like you're grounding regularly, right? But your first ground goes into the edge of the pond, and then your other one goes to the outer edge of the pond.
Opposite sides, okay.
Okay. So instead of doing that, go into the middle of the pond and start there where they're close together. Then go a foot apart. Then go a foot apart. You know what I mean? In progression, and try it that way. Okay. I don't know if it was just a fluke in my experiment, or if that's the sequence that needs to happen in order for it to be set up. Do you know what I'm saying? Mm-hmm. Is that what I mean? I'm tongue twisted today. It's been a crazy weekend, man. We had so much to do, trying to catch up on things for the live, and my presentation, all the writing's done. I had somebody look it over. They think it looks good. That's what they said. Okay, so, and then the video is 3/4. Well, I'd say about 90% done, but I had a problem, and that's why I'm not done today. When you put your audio in and you match it up with all the different parts, I was doing great. And then in the last little editing, I moved the audio the wrong way, and I clipped my audio, and I tried to get it back, and it turned the whole thing into a mess. So I had to go back to the last saved video. So it's going to blow your mind. But at the same time, people are putting out videos talking about the same thing. This is nothing new under the sun. But there's... Where do I put that? What people have been looking for is right in front of us. We're just not seeing it in the way that we would assume to see it. So, yeah. I don't want to get into that esoteric stuff or whatever, but so yeah, I apologize about not being able to show the experiments right now. I have some conclusive stuff that I'm going to be sharing on Wednesday for the sphere and the water coil. All the experimentation's almost done on that. That's some interesting stuff. And I wanted to comment on Ben. Good job, Ben. You're
Mhm.
looking at it in a different way, and you're getting there, man. That's you know, I'd give you an applaud, but I don't want an applaud up picture.
No, I'll applaud for you right now, Ben. Great
All right.
job, buddy.
Thank you.
There,
I
I'll
appreciate
applaud
it.
for
Right
Ben.
on.
Picture, I mean, come on. Oh, good.
Hey, I can't do it. I couldn't do it without you guys. I can't do it without you guys. So I appreciate all your help.
You're the one.
I'm
doing
using
it,
your
Rick.
transistor, Gerald. I'm using your transistor.
I hope it works for you. I hope it works for everybody out there.
Yeah, I hope it does too. And we're
Yep.
working real hard to make sure that we can make sure that these things are replicatable and you know, implementable. You can implement them easy in your home.
It almost looked like Papa Bale was using the same circuit too. He had the same transistors. I don't know. Shout out anyway.
And Bedini used the same transistor that Michael used for his Jewel Thief circuit, the MJL21194G.
Oh,
That
yeah.
one works pretty well too.
Yeah. For that, it would. Because it's more refined to like the 90 to the 300 volt pulse. You know what
He
I
was
mean?
using it for the Tesla switch.
Oh, yeah. Okay.
Mm.
We're going
Yeah,
through- Go ahead.
I blew out some equipment on that last test that I did. My gold Tesla coil has a scar on the inside all the way up it.
I seen that video. That sucks for all your work, but I gotta say, that's some juice, man. That's some juice.
Oh yeah.
That's
What
good.
was
Yeah,
that for
well,
Nathan? No,
I didn't
Nathan's
really want
done
it to
some
happen.
amazing stuff.
Yeah.
Go ahead.
Well, it went all the way through just about. It's like paper thin to the outside, so it's pretty much useless. It's basically just a shelf piece now. So what I think I'm going to do is I need it portable, and I need more of them at the exact same size. So what I'm going to do is probably build 4 of them.
Nice.
Because I want to do my resonance test. I want to start 1 and turn 3 on. And I just want to do it based on the actual resonance of the first one. But I need to make it portable. So I'm going to take 2 20-volt batteries that are basically my drill batteries. I'm going to steal some clips off some stuff that I blew up. And I'm basically going to lock them into the side and or underneath it, however I want to set it up, in order just so I can charge my drill batteries and use them on my Tesla coil, and I could put it wherever I want without ever hooking a wire to it.
There was another person that did something slightly similar. He had 4. They looked like little Tesla coils, but they were like capacitors that stood up. They were 4 tubes.
Mm-hmm.
He was pulling mass amounts of energy out. Of course, there was a little more to it. He was using a series of capacitors and switching, but he had it on the board. It was portable. If he could do it, you could do it.
Yeah, I didn't want to pull the capacitance out. I have a whole nother capacitor bank I'm building that I can. I got 2 of them, so I could pull out as much energy as I want. That wasn't the issue. It was that I wanted to make it portable because I don't like bringing a bunch of wires out there and connecting to my outlet outside and all that. It was a pain.
Yeah.
So, and then I put the solid rod down the Tesla coil. By the way, 10 times better. I get a better pickup and no sparking, no arcing, nothing. Okay, that doesn't twist like a wire does. Absolutely perfect for what I want to do.
He played with brass all the time. He loved brass. And I thought, you know what? Why? Brass is such a shit metal, but it's not. It's got its purposes. But yeah, he played with brass, and now we know why. The purpose is beautiful.
The thing is, that's why I was asking about the platform, because I might just put the platform on top of the water and drop the rod down instead of putting it up and going around. I'm just going to go straight down into the water right there. And then I'm going to pull the sides. So it's an interesting way of looking at it. Instead of going up to the top like I normally do, let's just go straight to the bottom and get it into the right place.
Well, that's like Tesla's picture, right?
Mm-hmm.
Remember? Oh yeah, here we go. Remember what you're doing right now is more than likely the same progression that Tesla did when he started playing with his coil and how everything was working with his grounding. He was probably like, you know what? I'm going to try this too. How about this? That's exactly what you're doing, man.
Well, yeah, I mean, look, we got to do it because the thing is in my gravity flyer experiment, I'm picking it up from the ground either way. It doesn't matter the pond, it doesn't matter the surface, it doesn't matter anything. As long as I can double ground it. One ground goes on my gravity flyer, the other one goes from my number 2 coil into the ground, right? So I'm grounding it, double ground that way. So that circuit works, and I can double to triple the power immediately without the piezo buzzer just by doing it. And then when you add the piezo buzzer into it, just understand this, it doubles whatever's there. So the mass amount of power that people are looking for is right there. It's not hidden. I've told everybody it's there. We're just looking to do a kind of a different experiment in this and light up the ground.
Do you want one more kind of idea for that? Now, everybody sort of knows about this. I don't know how to apply it in your instance. I know how Tesla applied it. He had another coil that would sit underground in the aquifer itself and would resonate with the Tesla coil. But now how he did that and how it was wired, I don't know. So it's something we might want to think about. Maybe it has something to do with his pancake coil. What if his pancake coil was buried?
Yeah.
You know what I mean?
Like that's the design for his ground, maybe?
It's a thought. I don't know. I know one
it's
thing.
It's interesting.
If you took Sean's coil and you were to dig a nice, decent little hole, and you were to put it underground with a tube where the sparks can come out of, bury it up over, there's your negative, man. That sucker would tap the earth like no tomorrow.
So, Nathan, would you say that the Tesla coil is pumping the energy into the mud, and then that's what's causing it to be a conductor?
So,
like it's pumping it into it?
Here's the best way to see it. Okay. The Tesla coil, let's just say this is a Tesla coil. You put the number 2 wire into the ground right here, right? Mm-hmm. So the energy goes in to the Tesla coil. It gives you 20% extra on any Tesla coil. That's a known fact. Everybody knows it, that you have to ground out your Tesla coil. Now, what it does is it flows through the coil and goes up and goes out that number 2 winding. What I'm doing is that's one ground. By putting it down the center, I'm getting more magnetic pinch on the inside. It's forcing it more into the center right here, right? What that allows me to do is get more energy going down the rod in the center now. Now, by putting that back to another thing, a piece of metal, you could just put a piece of metal there, a chunk of metal. That's creating another ground. Grounds work by putting a ground to a ground, and then they communicate in the ground to each other. You see what I'm saying? Now I'm pushing the energy this way. I'm pulling it back through to my Tesla coil. You see the loop?
Right.
I'm just creating a revolving loop between the two. Now, depending on what's in the ground as capacitance, it'll hold it. Now, can I put a capacitor here going in and a capacitor here? Yes. But I run the risk of heating up a circuit when I don't want to heat into it. So I leave the capacitors out. I simply want the cold energy to go into my gravity flyer, right? That's what I want. But then I want it to pull that cold energy back through my coil, back to my number 2 coil. And I want it to go like this. Now, the amount of heat that's in my coil, the amount of voltage I put into it, controls the heat in my circuit. Now I can decide exactly how much heat I want in my circuit, because what you'll find is if I go over 20 volts, 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 20 there's a lot more heat in my circuit and it won't function all that well. If I stay around 20 volts or under, my circuit is amplified even harder. So it's not about what you think you want to put in there. You don't want to put in a massive amount of voltage. Not how this works. It's a cold side circuit. So you're trying to pull that cold side through. It'll continue to stay in that loop. And by adjusting the amount of energy that you put into the original coil, you'll transfer the heat. Now, that's the most important part of this whole thing.
This is why I was hopping out of my seat, Nathan. I didn't want to interrupt you because you're doing such a beautiful job. But Wizard of Woodstock, he wrote it out before I had a chance to actually say it. You're absolutely right. If you were to take that brass rod and attach it to a line that went underground with just a simple square plate, remember Tesla's radiant energy patents? That square plate underground, and then you have another coil with another wire that goes down to a square plate underground. That link, just from those two square plates, I think that's gonna like quadruple the amount of output that you're getting.
Well, do you want to know a second secret about it?
What's that?
Do you know why it lifts just like the Hutchison effect? Now that you told everybody that there's plates there, it's the same effect. We are reproducing the Hutchison effect by doing this. That's how that gravity flyer lifts. Make no mistake about it. You see the big plate in Hutchison's experiment. You see the Tesla coil, the way it connects it. You see every single trademark of how it's working. I'm telling you, we're recreating that effect. That's what's going on here. So when you tell everybody that there's plates there, understand you just let the last domino fall in the whole effect. That's why it goes. That's why it goes very slowly and turns as it comes up, just like the Hutchison effect. It does the same thing. What does that mean? That means it doesn't matter if it's aluminum. It doesn't matter if it's a cardboard box. It really doesn't matter. It means that the correct energy is being put in for lift. And I try to tell that to people and they still don't get it. It is not AC and DC that comes out of this. We're pulling energy from the ground and matching Earth's energy. Earth's energy is not AC and DC. For those of you who would just want to discount it and say that it is, or, hey, I got this bug that says it does, or where it's good enough, it's not. It's just not.
Would you describe it more as like a static field?
No.
No, we're in a dielectric. We are literally in it, but it's more of a piezo.
Okay, that's all it is. Yeah.
It's more of a piezoelectric effect. And I'll be honest with you, when we get down to it and we finish this, I guarantee you we'll be looking at crystal in order to recreate the effect.
The Earth is an asymmetrical capacitor. It's basically just a round capacitor. So yeah, we live in between two capacitor plates. Right?
That's about it.
Yeah.
So we're in a saturation field is what we're in. But you can't break the saturation field unless you match the energy of the Earth. You can't get out of it. You know, that's what people are not understanding. You have to break the saturation. And how do you break the saturation? You make it look like you're invisible to the saturation. You have to have the same energy. Now, you can move around in that field without any problems whatsoever. That's the whole thing here. That's the giveaway. I mean, all it takes is a little bit more work and we have the lift. And that's it. So all the strange anomalies, all the things at the ground, everything comes to this pinnacle moment where we know what it is. We know who's created it. We know that we can create it. We just have to put the last few parts into place in order to show it. So the one other thing that I didn't do, which I want to do, was create the coil with the number one coil in the center and make it a bipolar coil. And I think that really has to do with vortexes and stuff like that. in how it moves things in different ways. So could it be changing the energy going in the one side of the coil versus the other? It could. So I want to try it and test it and find out for sure. But we're on the right track here. There's no getting around it. This is the same thing as the Grebennikov, that, with the little shells and stuff from the beetles. It's the same effect. Guys, when you start studying this stuff and you see how it lifts off of plates and stuff, that's how you know which effect you're in, because they look exactly the same.
Well, sorry for letting the cat out of the bag.
Whoops.
Whoops.
Well, look,
Of course. What's that?
I get people laughing at me for this all day because they don't understand what I do. It's like,
understand. Totally.
I mean, I don't see any of them making their mud light up.
You know what? The experiments these guys are doing are not, they're like, kudos to them. They're putting their time, their effort, and everything into it. But they're not doing the experiments that count. They're recreating experiments that other physicists did to prove that there is anti-gravity. We all know there's anti-gravity.
Yeah, we need people need practical solutions for energy right now, and we can't have them to be complex, like things that only a small percentage of the people can actually achieve. We need it to be simple, easily replicatable, easily implementable into people's, real life situations. That's what we need, honestly, in my opinion. Like everything else is nice and dandy, but that's what I'd like to see more of.
Well, I also solved, by the way, why Alexei used on his high voltage, it was 32 volts, or it could be switched to 16 volts, but it still had 0.75 amps. So he's very clearly not trying to create a ton of power there, just enough heat in the system for it to have heat, but not ruin the cold effect of the center plate. He just needed to create that dielectric in there and create a scalar field in there. So he basically wanted it down to almost less than static is what he wanted. And it showed up in his red bulb experiment where he showed the field and where it was and why it was there.
Yep.
Makes perfect sense.
I've seen that.
It makes absolute sense what he was doing.
You know what this essentially is full control over charge separation, which is full control over the dielectric, which is full control over the ether, which is pretty much the holy grail.
It is.
Expression.
No,
Yep.
it absolutely is.
It's a wonderful thing.
Well, let's just say this. The circuit, so I redid your circuit, Gerald, just one half of it.
Okay.
So I did it in the video. So I was just trying to show where the cold is, and people didn't quite catch on right away at first. When you're pulling the negative through the coil first, you have now controlled the heat in the coil. Based on the amount that you let any energy back up into that coil or create without pulling it fast enough with a heavy enough load, you're changing the heat and cold in the coil. Now, does that mean that it gets to freezing? No. But what it means is you're now starting at room temperature. You're pulling down by at least 5 degrees right away. Then, as the flow of the energy of the coil goes into it, you start to pinch the magnetic field, which draws out any heat and keeps the cold going in and pulls it down. The heat is pulled outside to the coil. The cold is pulled to the center. That's how you control the heat in the circuit the rest of the way. That's why it's such a beautiful system, because he found the exact way to fix the heat and cold problem, but then pin the center so that the cold goes more.
And if you were in space, and the way to control your steering would be the 12 pickup coils on the outside that collect potential voltage, it's actually collecting the heat. So if you wanted to turn or go in one direction, you would take 3 coils out of one segment, one section, and you would drive more potential into it, heating it up, because it's made to resonate at a certain volume of heat potential. I'm trying to think of the right word. It's not coming to mind at the moment, but it's set up a certain way, and different coils can be set up with
Entropy.
different coils. Well, entropy is just the way that this energy flows. So as I push the heat out to the outside and I'm picking up that potential voltage on those pickup coils, that's a form of entropy because it's trying to find balance. Okay. So as I take the potential voltage out of all those coils and I ground it, and the voltage goes from, say, 120 to 0, that's entropy because it wants to go to ground. It wants to seek that balance. It's nature's way of getting rid of all the excess, right?
Mm-hmm.
That's what I capture. I want it to go to ground because then I take that ground and I slam it through another system and I bring it back into a different battery while I'm capturing the flow that's going in. And it all has to do with fields and waves and pushing that heat where we want it by using the coil to pull the energy through the circuit. Think of the circuit. It works on negative energy, right? So I don't know if anybody's ever... I'm trying to think of a way to explain this. See, I know it from a different point of view. When I was building greenhouses and grow rooms, there's 2 different ways of doing it. You can do it with plus pressure or you can do it with negative pressure. Plus pressure means you blow a whole bunch of air into the greenhouse so that the walls push outwards, and then your exit, your exhaust, automatically pushes the air out because there's so much pressure in the grow room. But, I mean, you get bugs, there's problems. If you go negative pressure, and you make sure that your walls are set up right, what happens is when your exhaust is on, it's sucking that air out and your walls just bend in just a little. But no bugs can attach to your plants because the minute that they come in, the airflow is moving so fast, it sucks them right out the exhaust. So it's a win-win, right? Well, that negative pressure in that negative grow room is the same sense of how this coil works. When I turn the circuit on, I suck it through the coil before it goes into the circuit. That's that negative pressure. So, yes, you understand it like to a T, Nathan. And
Well,
go ahead.
It comes out in both what we're doing.
Yeah,
yours is more efficient than mine, but mine's still working. It's still
mine's
showing
just
that.
different. That's all. You got the principle down, man. Like, you got it. I think that if you took your brass rod and went directly into the ground, it might be a game changer to some degree.
Yeah, well, I agree with that. Well, yeah.
Yeah, and then pick up, on the other side of the yard or whatever. I don't know. Just a thought. Yeah. I wish I had more to show, but I had an amazing vision, epiphany, aha moment, call it what you will, this weekend. It's something we'll have to talk off air, but it has to do with the Ark of the Covenant. And it's big.
Finally getting there, huh?
Yeah, it's big. It's I know why the 2 arcs were separated. And I know the significance of the Rainbow Bridge and the significance of the rainbow that was given to mankind to show that God would never flood the earth again. It's all tied together. And the fact that there was 3 pyramids on the Giza Plateau, very significant. That's tied together as well. I don't want to go into too much detail on air, but we will get into it for everybody. I want to run it by Nathan and Ben and kind of see if what they think about it first. But we'll get it out there. Yeah.
Anything you have to say about the pyramids or basically ancient cultures in general, I'm interested in. You always have some great insights.
So I know we can't get into that certain subject, right? The one that would get us into trouble.
Oh, I'm waiting on the video for you, Gerald.
No, and I understand that. I totally do. I wish I had brought it out a couple days ago because there are other individuals that are trying to bring it out, thinking that they have a grasp on it fully. And I get it. I totally do. All the power to you. You know, I'll applaud you if you get her done. There's a lot to know. Study biology, study, electricity, study scalar, there's a lot to know. That's all I'm going to say. And then zip with that out the window. Anyway, so now that you are seeing things the way Tesla was seeing it, remember, he worked a Thotus T car. And I kind of wonder if, they're connected, these systems, if you understand what I mean.
Well, they are, because Thotus T car had a platform that he put the ship on before it raised up.
There was these papers that I downloaded. They're still sitting on my old computer. They were called, and they were debunked apparently by the science community, and everybody laughed at them. But there was some very weird info in it. It was called the Serpo files. Okay, so anyone who knows about that, have a giggle. I did too, but I downloaded them. And this is a long time ago. And as I was going through the description, and the Serpo files were basically aliens from another planet came, did an exchange program with the military. 20 military went to their planet, 20 of theirs came to our planet. Their timelines were different. On Serpo, every year was like 2 years here. And their energy was free and they had different things. And that's why the military went there, is to study their technology. So the Serpo people that came here were teaching about anti-gravity and their technology according to these papers, right? But the description of a ship, when you and I talk about heat and cold, and which is basically pyroelectricity, that's the ability of taking heat and turning it into electricity. Apparently, it hasn't been done at high efficiency rates, but we're doing it probably more efficient than most. That's not a brag. I hope people are watching. Learn, listen, let's get it done. Everybody should be doing it. So in these Serpo files, when they were describing their ship was a lot like Otis T cars, no Utron, however, but they worked on plasma, and the energy between plasma and, how is it put? They called it a different form of energy. There was a name to it. I can't remember. But at the bottom of the ship, and this is the part that I was thinking about when you were talking earlier, the bottom of the ship apparently had a giant round ceramic disc, and it had a pattern in it. And it was supposed to be able to absorb certain types of energy in the ship in order to change it into the energy that the ship uses. And then they kind of left
shape
it
power.
What's that?
Shape power.
I thought so at first too, but no.
No? Oh.
What is ceramics good for? Heat.
Oh,
right?
yeah,
So
that's
I
right.
think they were using the ceramic plate on the bottom to manipulate the heat and the cold in their ships. And that's how anti-gravity is controlled. May not be exactly how it works, but that's how it's controlled. Control the mechanism behind heat and cold. You control the up and down. You control the vertical. And then you got to control the horizontal. I want to get that and do a thing on it, right? From Twilight Zone. Do you remember that?
Oh, yeah.
Yeah. Or was it Twilight Zone or what was? Yeah. It might have been the other one there. There was two of them that ran at that time. We control the vertical. We control the horizontal. We are here. And it was like EMC squared running around the... It was a really cool show back in the 70s.
Well,
Just kidding.
ceramic can be piezoelectric. That would be interesting.
That's another part to it, right? Go ahead. That would be
outer limits. Is what
Thank
John
you.
said.
Outer Limits. Absolutely. It was a fun show. Although I'll tell you, the Twilight Zone, the best episode, the one I love, was where that guy woke up. Everybody's gone. And like the truck is still running, cigarettes still in the ashtray, the coffee's still hot, and he's running around his town and everybody's gone but him. That was a twisted episode, man. I'm telling you. Yeah. Stuff like that.
Yeah, that's a wild show.
Yeah. But again, if these Serpo files had any truth to them, that ceramic plate may be significant. It's piezoelectric. It transfers heat or may have the mechanism to control heat. Something we should think about, right? Just saying.
Not much different than what T.T. Brown was doing with those plates.
You're not wrong.
It follows right along the same path of what he was doing.
Interesting.
Yeah, it all seems to fall in place once you learn how to work this stuff, doesn't it?
Right? All of those old videos that you've seen from all those giants in this field, they all come together and make sense now. It's not like you look at it and go, okay, well, what are we missing? We know we did it. It's right there. We see the thing go, but what are we seeing? And then once you, oh man, it's like
it's more like, it's not that you watched all of them, but can you put them in the correct order to get the process right?
Yeah,
that's really what it is. A lot of people miss that because when you do the experiments, you start to realize, okay, this one goes first, this one goes last, this one just like that, and you work your way in, and that's how you find out.
The amount of experiments I did, because I'm lucky in that way, right? I'm not anything else but that. Well, blessed, I would say, but I don't have somebody funding me. I don't have somebody telling me I can't do this or I should look at this or look at that. Oh, you got to follow EMC, E equals MC squared, and don't go outside the lines of thermodynamics. Or nobody ever told me that. So I just kept doing experiments, trying to figure out how this stuff works. That's it.
Well, it's almost like,
wow.
How about you just get a camera, put it on me, and I'll do experiments, and then you can sit in the booth and write all of the knowledge you want down and explain everything away. Exactly. And then that way we'll get close to the answer. You know what I mean? Both of us working together like that, because sometimes two issues are the same thing. They're just on opposite sides and you can't see it yet.
Yeah.
That's really what it is. I found a lot of experiments like that. Like when you want to create scalar waves, or if you want to create, plasma in something, and people mistake fields all the time. I have to come out with a video on my field so that people understand it and how I can change the field in everything that I do.
Yep.
And once I do that, I think people will start to open their eyes to it a little more. I could show them the frequency. I could show them the amps and how it switches and how it's supposed to be. But then when I show you how to make the fields, then it becomes a lot easier because I could show you distance. I can show you the amperage. I can tell you the voltage. And I can teach you how to make certain fields out of it. Because, man, some experiments can be amplified like crazy if you know which field you're in.
Oh, yeah.
And then I could take out all the inconsistencies in your experiment. Your anomalies where your voltage goes spiking all over the place.
Yep.
Your amperage isn't steady. I can take all of that stuff out for you just by you listening to what I'm trying to tell you, you'll be able to smooth all that out and get a better experiment.
Absolutely.
So let's just put it this way. When you're in the plasma state, it's a perfect example. When you start sparking over once in a while,
yep,
that right there should tell you something about what your volts and amps are doing. Instead, you just take it as an anomaly that you're sparking over. Well, that's not the case at all. Your system is undergoing a voltage and amperage exchange. And when they do that, it ruins your experiment. Now, if you can make that consistent where it doesn't do that, your experiment works a lot better. A lot of people just think, oh, well, I got the effect. It must be good enough. Well, not if you're me. That's not the way I work.
Yeah. Tesla used to say he hated sparks. Sparks are for fairs and the masses. That's what he used to say, right?
It's a waste of energy.
Yeah. They're fun. Don't get me wrong. I love looking at I could sit there looking at Jacob's ladder all day long or a Tesla coil like slamming in the background. I love it. But that's not what we're trying to do, right? Although I'll tell you, a 10-foot spark at 1.5 million volts would be pretty cool.
Hey, we're all there for that show, right?
Yeah, right.
But yeah, you could take out a lot of anomalies in this, man. So when you get to a charge state, if you're not consistent, you'll turn into plasma, and then your plasma will ruin your experiment. Or you're wondering why you can't get more of a pound of a pressure on onto a scale. Well, that's why, because your fields are messed up, and you really don't realize it because you don't understand it. So when I give you a Wilmshurst machine, you crank it. You go, okay, I got static electricity. It must be the effect I need to use. Well, but what if I told you I did the same thing with 2 flybacks? I make the same exact effect, and I do the same exact process, but I do it with something else. That's the difference in understanding which field you're in.
Yeah, and if you put too much like potential voltage pressure, whatever you want to call it, it's so easy to go over from that charge state to the plasma that it's
just like that.
Subtle, you know. Tuning is what they would say it takes. Tuning.
Yeah, by the way, in all these effects, you don't want plasma. I've seen a lot of people say the plasma universe, and if they're talking about plasma like in high voltage, that's the wrong way to go. Maybe a liquid plasma or something like that. If they're talking about that, I might get a little more into that, but not necessarily. It's a scalar state.
Yeah, it's like the just right after the plasma or before. Can't remember which. I'd say it's before.
Yeah, it should be before your plasma state.
Yeah,
so
just before.
Well, if you're putting the experiment in first, then it'd be after. You know what I mean? If you put it outside first, then it would be before. Yeah, same thing. You know what I'm saying?
I do. I totally do.
So basically what it is, and I thought that, oh man, we just watched a video with the ice, and it was done with that Tesla coil, right?
Yeah.
And you saw the 2 anode and cathode go in, and then you saw a field, I'll do it this way, round like this, and round like this.
Yep.
That right there, that's your field that you want to be in. That's what you cannot see in high voltage lines. Okay? That's the exact field that you want to see. That's your dielectric. And like I said, it comes out like this. And it's not like they didn't tell you. They told you it was there, but you could see it in that experiment. That was the coolest thing in the world, man. When he did that.
Could you imagine one that was big enough to walk through? Be pretty interesting. I wonder what would happen.
Yeah, that's Steinmetz work, but it was also Archangel is the person who did the experiment.
Yeah.
And he usually does Tesla coils. But when he takes the glass container and then he has it iced over, and that's when he put the electrodes in, absolutely one of the best videos out there. So
it was pretty cool.
Yeah.
I like seeing how the little vortices were showing up, and then they disappeared because the ice is still melting, and then they'd show up again.
Yeah.
That was a cool video. Yeah. Yeah, I wish I had more to display right now. Kind of can't do it though. And Ian's probably just like, Gerald, where's my damn video?
I think he's given up, Gerald.
Probably. Yeah, there was some stuff going on this weekend that pulled me away from doing what I needed to do. So, but I'm back on track. I'll get caught up by Wednesday. Yeah. And then, yeah, I'll have stuff to show Wednesday for sure. But the growth of food, so check this out. Take 2 Tesla coils, use those as your ground, one on either side of your yard where your water is, put one line in, put in the other line, grow your food in between. And I'll give you the frequency.
You know, Gerald, you keep bringing this up. I do have that test that shows how it's done. So, I'm waiting on you, brother, to say it's okay.
You know what? I got to do mine. Because I got a slight variation of yours that I'm doing in mine that helps explain yours. That makes sense?
Oh, it makes all the sense in the world to me, brother.
I know.
I keep getting accused that I don't put out the work and show it. And
that's my fault. I'll take it. I got some shoulders over here. I'll take it. It's my fault. In Back to the Future, the principal, what was he said to what's his face there? What was it? Slacker. I'm a slacker. Sorry, I'm really not. I just very, very busy. Trying to catch up on every project because I got a folder where it's like I'm trying to accomplish certain things to do, and I'm almost caught up on this one. I can throw that out. This one, throw it. You know what I mean? So I'm finishing certain things, but there's a purpose for that. We're so far into this. The next level is going to be awesome.
The thing is, Joe, people are listening, but they're not understanding exactly how far we're into it because we're not showing the next part. The next part really shows them how deep we're in. And by the way, there's a comment here for you. Okay? Right here.
Okay, but go sit on your toilet first because shit will come. Hey, my eyes are brown. I'm so full of it, all right? I'm just kidding. They're actually hazel. They change color all the time.
Oh. So what I'll work on in the meantime until we can show that is...
Yeah, I was supposed to get that done this weekend. I apologize.
Yeah, I'm going to go ahead and show my plasma states. The plasma state and the energy state. I'll do that this week, and I'll have that to show.
Is that the other of the videos that you were showing me?
No, this is just going back to high voltage and learning which state of energy you're in.
Yeah.
Because I need to show that in my Gravity Flyer series. I need to show that as well so that I can make sure that people understand it. Because we're going to go into a scalar state. And right now, everybody who has one of these Gravity Flyers is running a ton of voltage into them.
Yeah.
And they're overheating, living daylights out of it. And what it basically does, it takes the cold energy and it uses it.
They think it's a power factor at play, and you're like, no, you just gotta, like what Gerald said, tickle it a little bit.
Yeah, we're not
set it all up right, and you're tickling it in the right spot. It's gonna hop. It's not gonna want to stay there.
Yeah, they're overvolting the living daylights out of it, thinking that's the lift, and it's not. It's simply another control of heat in the system. So you think about it, the plate's completely cold.
Yep.
And on top and bottom, you're controlling a little bit of heat, right? Well, when I hit the piezo, I'm pushing the heat. I'm simply maneuvering it.
Yeah. Go ahead.
So basically, instead of two coils and they're meshed together like yours, I have a flat plate. So I have to play with the charged side of each plate. And that's why I'm doing it that way. If you push it, it'll take that charge from the bottom, build it in the bottom quicker, and shove it back up because it does not like that state of charge there.
Yeah.
And let me just drop this hint. I could take earth ground and connect it to the bottom and not even use the negative side of that voltage coming out of the flyback. Could just use the earth ground and I'll get the same effect.
Oops.
Yeah. So you want to know the energy level? Well, there you go. So
yeah, energy's not the issue.
It's not.
Everybody thinks it is because they're trying to hammer it in, right? It doesn't work like that.
You can't force this in.
No, do you hammer a swing when you got somebody on it you're pushing? You just want to give it that first initial push and then just lightly tap it. You know what I mean? And then it should all come together. Yeah.
So, yeah, there's so many little tricks to this thing that I picked up. You know what I mean? Throughout looking at the right experiments and doing them and rebuilding them the same way.
Well, once you get there, it's like, how do you not continue on? Like, it's such an amazing thing to see. You know what I mean? You're pulling energy out of the ground, but are you? Well, yeah, you are. I think about it in so many different ways, right? Am I putting the energy into the ground? That's why I'm getting it. Why am I getting more out than in? You know, there's so many factors. And why is it doing this? Why is it doing that?
Well, if it pulls 20% extra into your Tesla coil from the ground, and you look at it, if you connect the ground to it instead of the actual circuit, what is it telling you? That you're still pulling the energy from the ground. You're still doing it. It doesn't matter if it comes from the coil or from the ground itself. It really doesn't matter. It's the negative side of the circuit. So, or the side with less energy than the top part, with less heat. It's the cold side of the circuit. So you're still manipulating it the same way. It's not any different. That's why it can be done that way, because you can replace it from one to the next. So
absolutely.
It's a better understanding, and that's why I don't like so much positive and negative. I like it has more on one side of the charge of the thing and less on the other. That's the way I like to see it. It makes it easier when you test that way.
Well, you know what I've noticed in the communities that we deal with, free energy, over unity, science community, all that. Every time a group gets close or a group figures it out, there's a whole bunch of drama surrounds that group. And that's why I think that secret doesn't get out as much. And I think that we need to literally push the secret harder and faster as much as we can to get it out there, to get everybody, and I mean everybody, doing it. Because that's what we need.
Yeah, by the way, just saucer shape. Okay, so let me go over this, and I'll just do a whole video on it later, but I just need to go over this. Saucer shapes. They're for the outside casing of a ship.
Yep.
What I'm dealing with in the Gravity Flyer, it's a field generator. So just understand this. Because it generates the fields in it, it can maneuver like anti-gravity. But is it the best anti-gravity sort of craft? And heck no, absolutely not. It's probably one of the worst ones to do it. The fact that it even got this to lift was amazing. But the outside of the shell that you put over this thing, now we're talking about the right stuff. That's where you want those shapes. I don't want it in the other stuff that I'm doing. It's irrelevant. It's only relevant when you get to the outside. So I always get that. Change the disc, change the disc. Yeah, I understand what you're trying to say, but you're in the wrong area. When I go to create the outside of the craft, that's just trying to change the disc. Yeah.
Yeah, people don't think about that, right? Yeah.
Well, they're jumping the gun. They want to see something that looks like a saucer. And trust me, so do I. I would have been much happier to take my charge experiment, pull 3 pounds, put it underneath the craft, and have it pushing up. Okay, and then just take something like a simple ion lift, just the wind that comes off of that, in order to lift it. But I don't know that it will, because I could put pressure in one direction quite a bit. But does that mean it's anti-gravity? If I show you 3 pounds dropping on the scale, is that anti-gravity, or is it just pressure in one direction? My thought is it's pressure in one direction.
Yeah.
Because when I flip the experiment upside down, it doesn't take off my table. It still sits there, even though the amount of force is greater than the weight of the object.
I don't think, and this is something I've been having I've been trying to figure this out for a little while now. I don't think anti-gravity lifts off the ground like the movies would think. I think it's more like you have to get it off the ground. Once it's off the ground, it's now negating gravity. But you have to get it up there. So whether or not it's raised off of a platform, you turn the system on and drop the legs, and then it floats, or it's got some sort of an external lift system first. I don't know, but my thought process is that it can't lift off the ground, because then it's part of the ground. It actually has to have that break from it.
Okay, check this out. In Alexi's experiment, he does it in the house. You found out when you grounded to the pipes what it does inside the house.
Yeah.
So he didn't tell you this, but it's exactly what's going on. He's creating the field inside the room. So a lot of people don't understand that.
I get
when
it.
you get outside and you're in a very heavily populated area, you are under a field that has to do with all the electricity that's high above it. We are in, 60 hertz?
Yeah, 60 hertz.
You now have to break 60 hertz out of this in order to lift. Why won't you find an anti-gravity project that's not done in the field? Because you can't. You can't break that 60 hertz. So you have to go in the middle of nowhere, just like Alexi does. Okay? Now you're in the correct area to use the Earth's energy in order to drop the field. Now, will that change once we know exactly everything? Yeah, it will. But for now, these are the parameters we're in. He created a field in that room, and he didn't tell you that. Only experiments will tell you that.
Yeah,
and then when he's outside, how tall are the trees outside? How tall is the field that he's working in? Maybe you...
So that makes a complete sense. Every craft has a way that you have to launch it. A specific like we build launch pads for spacecraft and for airplanes.
But it's more than that. Then it's more than that. Just think of the trees themselves. Energy goes up in a spiral. Energy comes down on a spiral. It's pumping up. It's pumping down, and it's got an energy field. You put another tree.
I'm just saying the environment is. Yeah, the environment is something you have to consider.
The environment is an extension of the ground itself. The roots go into the ground, so they're grounding the tree, and the energy goes up. If you don't believe me in this, take some paper and put it in a scalar field, and it will completely saturate in that field. That's how the charge experiment works. So when you have the height of the trees, you're extending your ground. You have to know which field you're in. And I don't just mean that like a random field. You really have to know the charge field you're in and what the heck's going on in it.
From all those high voltage lines and all that stuff, right?
So when you talk about the pyramids, you know why there's obelisks everywhere now? Where's the height of the field that you're in?
Right. They push it
Yeah.
up. That makes so much sense.
That's it.
And I think Alexi went out into the field because there's another factor involved here. Those electrical lines create sound that we don't necessarily hear because we're so used to hearing it all the time. But there's a hum, there's a vibration. So you're right. If you're close to one of those, I think the initial jump of getting it off the ground is the issue. Once it's in the air, it doesn't matter. All sound's going to do is push it away. Just a thought.
Because the field you're in is pushing it to the ground. Your dielectric goes from the top of the wires to the ground. You're in that field. It's pushing it down. You're constantly pushing down. If it pushed up, we'd all have stuff that flies in the air once in a while. We don't. It pushes down. So it's forcing your craft down whether you know it or not. It's the same thing as taking a lifter and putting it on your table and turning it on, and it sucks to your table instead of lifting up. How do you make that initial lift to break that? That's the key here.
Yeah.
That's exactly what we're looking for. There's a way to do it. And like I said, when you change the charge, you have more or less charge on something. Okay? That's how you break it. When you can get it to go and everything else is pushing up and just the center's pushing down, now you have it. But right now, everything's pushing down and there's not enough here to flip it. You have to force the flip to get it to do the initial lift. That's one of the key understandings of this. So there's a lot of little tricks to this thing. There's not just plug it in the wall and it works. God, I wish it was that easy.
I wonder if when you create that initial bubble from the charge, like you're charging the ground, right? And you charge it the different polarity than your system. You slam a bunch of potential into it, creating that bubble to a certain capacity. And then as your system rises to the top of that bubble, you pop it, and now all of a sudden you're anti-gravitic. Do you know what I mean? It's like pushing up the ground, and now all of a sudden your ship or whatever it is that you're using thinks that the ground's there, and then you drop the ground out from underneath and it stays. So it'd be like popping the bubble. I don't know. It's just a thought.
I want to say this. If you put it in a negative voltage multiplier, it sucks to the table.
Yep.
If I take a DC flyback and put it on a piece of tin foil, it'll suck to the table.
No, I know that.
A lifter will not lift in negative charge. It'll always suck to the ground.
Oh,
a lifter requires you to be in positive charge. Your positive charge field must now be the entire field where the negative is pushing down to it. Your negative is your plunger, and the positive is your poo that comes up. Okay? And you want it to fly up in the air, right? Well, there you go.
You and your poo.
You're pumping your poo.
I get it. I got the negative and positive flipped around. So you want to push some poo, and then I got it. Okay.
Well, I can't get people to understand it any other way. I make a joke out of it.
You know what it is? I totally get it. It's just my brain goes back to sometimes I slip and fall back into that thought when we were talking about how we're creating bubbles and because the coil hopping, right? Sorry. No, I get it. I don't know what I was thinking there.
Well, but to think about it, your coil was sucking to the table, right?
Yep.
You touched it. You now, in part, you took all the charge from yourself Now you switch that field. You now force that field to change its charge.
Oh, yeah, because of the heat transfer.
So as soon as you did that, you see what I'm saying?
Yeah.
As soon as that heat came over, and they've done experiments, by the way. So there's experiments out there that shows the heat transfer works to the human body. So that heat transfer changed your field. And as soon as you change your field, it popped off the table. What's the problem? Is you didn't have a sustaining, electrical thing. You went to shut it off right away, right?
Yeah. Well, you know what? When it popped up and I caught it the second time, all the cables were ripped right out of like how I had it all wired and everything. And I gave it lots of slack so that if it did hop, it was only going to go up. I figured, it's going to hop. No big deal. No, 6 feet, and it ripped all the cables and all the wiring off the circuit.
But the thing was cold. And didn't you say that it gave you the chills afterward?
So when the hopper happened, it hopped. My reflexes, I caught it, and then there was a sound that went from the top of my head to my toes, and it was like a very low sound, and it was a vibration. I couldn't move. My body was locked, like absolutely paralyzed. Then when the sound was gone, that's when I dropped the coil, went upstairs. That's when I was cold. Very cold. I had like a blanket on, and I was getting warmed up, and oh man, it was crazy. Crazy. So yeah.
I wanted to tell people this while we're on the subject just a little bit. The magnets in the bottom aren't what you think they are. People always think we're going to create a magnetic field to change the world. We're not. It puts eddy current in the center plate. The center plate, in turn, creates a frequency for the craft. That's it. That's where your frequency comes from. It turns into a beat frequency throughout your whole craft. Depending on how much push and the distance you put in there is the frequency that you get.
Yep.
That's as simple as it gets. That's what it does. There's no special other feature to it. That's it, except for the fact that if you put in neodymium magnets, you're going to produce a ton of heat in the center plate. And then you're going to kill your cold field. That's it.
There's too much power in those neos.
Yeah. So that's another little secret, little tidbit that you have to know that you only do with the experiments. And by the way, just so we understand each other, high voltage tells you everything. So when I spin the top plate and it creates a vortex right to the dead center, because the voltage always goes in and to the center. People didn't understand that. They thought I was trying to lift it with voltage. I wasn't. I wanted to know where the energy flowed. So I put a super high voltage on it, and it flowed right to the center. Then on the bottom, it flowed on the bottom plate right to the center. So what was I doing? I was creating a vortex here and a vortex here to my center plate. Now does it start to make more sense and why it's creating the correct vortex?
Let me ask you something. Your magnets are north-south, all the way around, right? No? What are they? All north and then all south?
They're all north.
All north all the way around. That would still do it. You're forming a parametric oscillator in the center between the two plates is what you're doing. So you're pumping. I'm just trying to picture it in my mind because the way that the coil works, it's like this. So it compresses each turn in, right? Whereas yours is slightly different. So you would be compressing more like this and pushing the field out because you got north and north, right? So as it's spinning, it's still a parametric oscillator, but it's like compressing like that against each other. You know what I mean? That's interesting.
But by the way, that's why it's only during that one effect will it lift.
Yeah.
It can't lift any other way. It
No.
has to be in that effect. So, could you guys quickly touch on the oscillation of the frequency? So, this is what drives me nuts. If you think in Steinmetz terms, if you see an AC wave or a sine wave, it goes like this, right? We're all used to the nice pattern. What's the true problem with that? Is that as soon as you bring in, say this right here is the wire. The true way the AC works is not like this. AC works as a spin, like this. So as it's spinning, this is charged more than this side right here. So this side is seen as positive, this side is seen as negative, and it spins like this. Now you're taking a disc, okay, a round disc. Tell me where the sine wave goes. Do you really think that it's oscillating like this, up and down and up and down? It doesn't. It wants to oscillate in a vortex. You see, that's one of the big things here. It has to spin the vortex on the outside because I put the heat on the outside and I put the cold on the inside. Now, I'm forcing it to spin the correct direction. It's a different in understanding exactly how the fields work. And we know that it's doing it because I'm putting the vortex right down the center, right through the bottom. So that's going to create a zone in the center that pulls out and give you basically what would look like a hole in your craft where the energy does not want to go and impede on that. So then it forces itself around the entire craft, and that's the way that it's vortexing. That's why on a flat disc, you get that field.
That makes sense. So again, it's all the same principle when it comes to
it is
vortexes and pressure.
The difference is when the top and bottom plate, when you're pushing fields, the reason I call it a field generator is the Tesla coil holds in the scalar field.
Yep.
But
absolutely.
If I put the scalar field on the outside and I take the rotating disc and connect to my Tesla coil, I can now push my scalar field throughout my entire room in seconds, or not even seconds. You can't even count how fast it is. It's less than a blink of an eye.
The minute it's hooked up.
Yeah. So that's why it's a field generator. It simply generates fields like that. So it's better at that than it is at lift. I can tell you that. It would have been simpler to make a coil lift. I could tell you that from first-hand experience. It would have been much, much simpler. But that's not what I was given in trying to reverse engineer a project. So I'm working with what I got here. Would I build it this way? Absolutely not. There's no way I would build it this way.
It's like the flame jet thing there.
Yeah.
Seen it in a paper. I had tested it once. Jeremiah had talked about it, but I wasn't trying to replicate it or anything. I just set it up and wanted to see if it would work. Man, did it ever. So it makes one wonder. There's an application for that. Of course, now what application I won't get into, but if you're in space, then you're able to, through high voltage and a little plasma flame, literally ionize all the air around you. I don't know what would happen, right? Just a thought.
Well, let me address why the fields push and why they hold stuff in. Magnetic field holds heat.
Yep.
The other scalar field doesn't have that much heat. So now that we're talking about the heat and the cold, you can now push the cold energy with the hot energy and force it to go where you want. You can hold it in, you can push it out. That's the difference. There's no getting around that. You could do the test. I'm not lying to you. You just take your Tesla coil, hook it to your center plate of your gravity flyer, run the two top and bottom disc, and put static electricity on it. Just make it easy. I guarantee you it'll hold it in. But then connect your static electricity or your flyback to the center plate, and now connect your Tesla coil just to the top, through the center of the Tesla coil without connecting it to any part of the Tesla coil, then to the bottom. I guarantee you, you will now have that field of that Tesla coil in rotation, force out everything in that static field and blow up everything in your room. So that's it. I'm not lying to you. It's exactly how it works. You could do it any day of the week. It'll work the same way.
Absolutely.
But I'm telling you right now, it's the amount of heat and cold that you have in each is why it's doing it.
Well, I don't like playing with my coil unless I have ferrite cores near it. I'll put them on the outside. I'll put them on the inside and do those tests, but essentially where the ferrite cores go is where your magnetics is contained, right? So your magnetism goes into the ferrite, and that's where your heat goes. So there's ways.
So check this out. I'll answer this question. Nathan, can you integrate the Tesla coil? Now, you have to integrate how the Tesla coil works. You do not have to remake the Tesla coil in there. And what do I mean by that? If you have two coils, say I take my hands like this, and each one of my hands represent a wire winding. And I put them like this. And I oscillate this one, then this one oscillates. Oscillate, oscillate. Now, I've mimicked the way the Tesla coil works, and I'm going to create the same effect. Does it have to look like a Tesla coil? No.
No.
But does it have to work in the same way? Yeah.
Yep. Absolutely it does. Because it's the principle that you're going after.
Mm-hmm. That's why Gerald's system and the Tesla coil work almost the same.
Yep.
In that one aspect, I'll say that, because there's other aspects where mine won't function in the way Gerald's does.
Yeah, just because of the way that it's designed, it's different. The Tesla coil's limited, but it ain't that limited. You know what I mean? It gives the full principle. It does a lot of things. Just, mine's different. Big time. Just kidding. Yeah, so there's a couple more holes in my coil, and I haven't done any testing.
It's still running?
Nope. Yeah, I have done nothing to it. I put it in the box since the last time we talked. I pulled it out. There used to be 3. There's now 5 in the inner core. So the bubbles, or whatever they are coming out.
So I'm going to tell you, Gerald, my honest opinion is I don't think it ever shut off. And I know that sounds wrong, right? But think about it. The way you set up your circuit was to continue to oscillate this thing back and forth until the energy was completely gone. But we're just looking at energy we can see. It's the energy that we don't see that continues the effect. If this thing is that far in resonance together, it could be doing it on a micro scale, and you'd never know unless you saw those bubbles.
I agree. I 100% agree. It could be doing something even not when it's hooked, even when it's not even hooked up. Absolutely.
Maybe. There's a way of shutting it off. I'm going to have to hook it up and then pop a cap. I know it sounds weird, but you just got to short out a cap.
With how much geometry you have in that coil, Gerald, it shocks me how well it resonates together. I don't think you could plan it that well.
No, probably not.
Well,
now
you couldn't. I know who could.
See, now I can. In the beginning, no, I couldn't have planned it that well. But now I've got extensive experience in this. I could actually, if you want a certain frequency, I can wind that into the coil now. So,
what I want to do with the rodent coil now is I got resonance to stay there when it's cool, right?
Yep.
So what I want to do is start working with the cap bank, and now I want to pull a little bit more through. Mm-hmm. I want to see if I can set this thing up because I'm only using one wire on the coil. And I have plenty other wires. There's 3 more wires there.
Yeah, use it as a pickup.
Yep. Now let's see if we can't pull some energy out. We
I
can't
wondered about that.
continue to resonate it longer. You know what I mean? There's plenty of tests
I
we can
think-
do to see how it works.
I think you're going to
Yeah.
get some positive results, specifically because that coil is basically a pancake coil in 3-dimensional, toroid shape, and it's basically doing the same thing as a pancake coil, only it's picking up a lot more.
Yeah. It's picking up a lot more. Yeah, sorry, I was reading the comments.
Yeah, I think
and
it's
my
just
brain
the
went
geometry is. Yeah.
Go ahead.
It's okay. Yeah, I was just saying. I think the geometry is just a little bit more perfect for the energy transfer. The pickup to happen.
My coil?
Well,
So-
both your coil and the rodent coil. The sacred geometry. Versus the flat pancake shape. If Tesla, like I always said, Tesla's was alive. If Tesla was alive today, he would agree that that would probably be the next step in the pancake coil. Making it a more 3-dimensional shape.
He was working on it. In fact, he knew about cinematics, and I think that some of the stuff that disappeared when he died had a lot to do with sacred geometry.
Yeah,
because the secret
It
of the
could, yeah.
pyramids, it's literally
makes sense.
that's how he made the Tesla coil. He was mimicking the pyramid and how its operation
Right.
worked.
He's like, how can I implement that technology into, our technology, because they did it differently. They didn't have circuits, obviously, but it was still the same principles that he was basing it off of.
Yep.
Yeah.
Absolutely. I study sacred geometry all the time. Anything I can get my hands on. Love it.
That's why you got it.
Yeah, I think it's amazing. Sound creates it.
Oh,
You're
Nathan's,
muted.
you're muted.
I hate that too. You're
Yeah.
still muted. Still can't hear you.
Maybe the
Sorry.
headset died.
Sorry, that's
there
why.
we go.
Okay. Sacred geometry is exactly the way Gerald's coil is built. That's why he's getting the different features than I can get out of a Tesla coil. And that's why his resonance frequencies will be different.
Yeah.
It's also why he can add other factors in there that we can't talk about in there.
Mhm.
And it works a little bit different. So if you've ever thought of sacred geometry in the right way, and it goes in layers, take your dimension of geometry, you take the resonance frequency of that geometry, you have to take into account the sound and the tone and the octave of it, okay? And you put them in the order you like, right there.
Mhm.
Then above that, you're putting your vortexes in,
Mhm.
bottom and top. So you already have another vortex that's created like this all the way around it. So you have a spinning vortex. You have vortex that are now spinning. Because you're using a Tesla coil, you're now pumping it.
Yep.
Because you're pumping it, you now have to put the Russell scale in the vortex.
Yeah.
If you put the Russell scale in the vortex, understand there's 3 letters that fall right in there that we're not allowed to talk about on YouTube, but that's exactly where they go. That's why it matters in a round field like the Earth, what level you're on, because the transmutation of the Russell scale would be different here than the field here, than the field here. So, I don't know. I mean, you figure that one out. There's a whole dynamic here.
Fine. Yeah,
It's all everything you thought was in any one of these systems is all in his. All of it.
Yeah. Yep. I have a few videos if you want me to share them. But I don't know how long you plan on going.
Sure, if you wish. I don't know. It's up to you, Nathan.
What are the videos
Stop
on, Ben?
talking about my darn coil. No one cares anyway. Ben, let's go.
Well, one of them you've already seen. That was explaining how I hooked up the multimeter to the current and get the reading there. The other one is the one where I show the the yellow neon lighting with 5.5 volts. And then there's
It's
one
all
that
your
you guys
stuff, right?
Yeah.
Yeah, go for it. Yeah,
Yeah.
I'm sorry. I just didn't want to play videos from around the
Oh, no.
internet.
You're yeah. I figured I'd wait to the end, end it on some videos. If you wanted to see them. But yeah, one of them you guys nobody's seen yet. So I'm kind of excited. It's just a rough cut, but
just before you start, I want to clarify. No, it's not 369, the numbers that are in this coil. No, it's not 9. No, it's not 6. It's all the numbers. Okay? That's all I'm going to say. Go ahead, Ben.
Right.
Oh, real quick.
No, thank
Ian
you for
asked, did you get the
clarifying
right
that.
holes, Ben?
I got all the right holes, I hope.
He's got 2.
Hey,
All right, Ben, go for it.
They say I got holes in the right places.
The wizard says no buns, please. Oh.
Shout out to Ian and everyone in the chat. Go ahead, Ben.
Ben, does it have volume or are you going to narrate?
Yeah, I was going to say no sound.
Oh, man. Hey, Gerald, what did you think of that video that I put up there last time?
About your last one? Your very last one?
I had to censor the video. Oh, I'll get back to it. Never mind. Go ahead, Ben.
All right, so we have a yellow neon lamp in there, which has the breakdown voltage for DC at 120. So let's look at the sheet here. It's the RNL5Y12. Y stands for yellow. Obviously, breakdown voltage DC is 120. So that's the minimum we're going to need for this DC circuit to excite.
Can you guys hear this?
Now check this out.
Yes, I can hear it.
We're at 5.5 volts. Yep. So we're way past 10 times voltage magnification here. We're way times 10 times voltage output. It's lighting this yellow neon at only 5.5 volts. Absolutely incredible. And it also seems to be maintaining the current apparently while I'm measuring it. We still have yet to verify that, but it apparently seems to be doing that at the moment. You hear it. And also notice when I increase or decrease the power level, the humming seems to be ranges where it's finely tuned with the power as well. And it goes down again. See, you don't hear it at 9. Goes back up.
Okay, that freaked me out. I thought that was somebody's hand and arms that actually came out.
Oh, you talking about his little clap at the end?
Yeah, I was like, who did that? It was funny.
I saw, Mike Faraday's videos, he's got the little face on there that gives you the weird look.
Yeah.
He had his last video, and all I saw was his hand. It was coming out like this and pointing and doing things. It almost looked like a fake hand that was doing it, but I knew it was his. Yeah. It lost me in the effect when he was doing that. It was hilarious.
That's funny. Yeah, I watched that earlier today, too. Okay, go ahead, Ben. I'll shut up.
Go for it, Ben.
Breaking news, ladies and gentlemen. We might actually have something here with the jewel thief. Okay, so earlier I discovered that switching the start to the finish of channel A to channel B to the finish of channel A to the start of channel B, and I've been testing it like that. So I recently hooked up the current reading because I have the voltage here. Now the voltage is coming right out into the load, right? So this is the voltage that we're measuring on the load. We have the probe hooked right up to the neon. In the base, between the middle and the right pin, the base and the collector, that's our load. Now, as you can see, we have the yellow wire going from the collector, and that's why I color coordinated it, or color coded it, so you could follow it. It's going directly to the yellow alligator clip, and that's going to our positive of our multimeter, and then that is going, the negative for the multimeter is going to the output of the coil. So this is the output, this red channel here, this is what we're using for the output. That's channel A start. Now we have channel A end and channel B start connected to the power. So this is our power input coming directly from the switch, which is getting power from power supply. So switch to coil, power supply to switch to coil. Okay, so this red wire is our power input, and we're specifically using these two wires together to combine them, the channel A and channel B, in such a way that it makes one large synchronous coil. So now, what we have to do...
Ben, you keep stopping it?
Yeah, so my mic's not working on my other desktop, sorry. So I wanted to emphasize right here that I didn't include this little bit. It's not just combining to make one large coil, but it's also sending the energy in two directions. It's sending it one way and the other way. So you're creating that counter rotation.
Very
is
cool.
measure the current. Excuse me. So as you can see, I have 6 volts, 0.24 amps, so 240 milliamps on the input. This thing is turned on. So I have this frozen, so let me unfreeze it because the probe is a little cheap. So I have to adjust it to get the accurate reading, right? If I increase this a little bit, it'll prove it because it lights the neon. It's not gonna light it at 17 volts. But you'll see at 17 volts, when I increase it and the neon lights up, this gets way above. This is a 100 volt resolution, and it's damn near close to the middle line, the 50 volt line, which is what we will expect when we're timesing our output by 10, right? But we have, seems maybe a little bit of loss in the volt, maybe a little bit of loss in the current, as you'll see in a second, but I'm sorry, maybe a little bit less than 10 times multiplication for the voltage. But as you'll see in a second, watch us monitor the current. So we got the current now in its proper configuration. And look at this, 221 milliamps coming out of the coil and 240 going in with about 50 volts amplification.
Night genetic jabber.
So as you'll see, that's proven by our visual here. When I turn this up to about 17, the neon lamp will shoot on. Oh, there it goes. About 16.7, and it shoots on. That rating right there that's a 90 DC volt rating. Has the breakdown voltage of 90 volts minimum to light that.
Now AC is 65 volts, so it should light a little bit easier. Look at that, I adjust it because this is cheap oscilloscope. Look at that, ooh. So I can't run this too long because this is only a certain, about 8 watts here. And to get that to light with this configuration, I need 11 watts into here. So it's kind of burning up the resistor a little bit. But this is a definite positive result. We might have something here, ladies and gentlemen. Let me run the numbers, but we might actually have a verification of over unity using Michael's modified Joule Thief.
That's cool.
Awesome.
Yeah, that's really cool, Ben.
Yeah, so it's I wanna emphasize I misspoke, not a verification, but evidence of over unity, not verification, because we still need to have other people do this and replicate it. But I think it's positive results, and again, we're doing everything right this time, the way Daniel recommended and the way that others have recommended to me as well. So I'm really excited, and I have one more short video to show you guys before I close out my my presentation here.
Absolutely, go for it, Ben.
Shout out to I don't want to say it because of the way it's might be pronounced.
Oh,
shout out though! I checked out your video today. Love the work. Good job.
Oh, hold on, real quick, Ben. Before you start, did you see his wine bottle? Gerald?
What's
Wine
that?
bottle.
The wine bottle.
I believe I was thinking of the pancake coils.
Oh, his coils are cool. It's just he made a wine bottle, and it was a coil. I'll show it later. Go ahead, Ben.
I'll have to check that out.
You know, this type of setup, you know, except this one we wound into an Abha design. But yeah, I remember when he was showing people how to do that, and he showed energy reduction effects, and he demonstrated the monopole anomaly and those things. Well,
par for the course.
Well, not to mention the videos are down now anyway.
His first round of funding, he was the terms where he had to take them all down, and he wanted the money, so he did. It's a real big problem for all of us all the time.
Yeah. Well, I'll make sure
That's Marco Rodin, by the way.
My most important videos up. I did filter out some of the more confusing things. I think that a lot of the learning process, you know, has kind of narrowed out our most important effects at this point. So to have people looking at the old videos is kind of like counterintuitive to what needs to be presented at the moment.
Well, refining or culling
Yeah.
things is normal. Outright removing everything is something else.
Yeah, yeah. And that's not what I'm interested in doing either. I think that you know, it's important to allow people to have access to the information. So yeah, I left up that how-to video. We've got circuits posted online so people can go and find out how to wire it up, and at least the very basic the first step is there for people. You know, and I'm gonna make sure that that stays there. You know, so that if anybody wanted to take the idea and, you know, implement it a little further or expand on the concept, that they have that ability. Because I think that was a crucial part of our learning process, you know, being able to see those videos online and follow up Jamie's work. Are you guys getting, what are you guys getting? You know, I feel that it's very important to keep that you know, line of information open for people. You know, either way, I'm gonna make sure that we allow people to replicate
It's a real
at least
problem.
these very first steps.
All right, so that is the follow-up to my 0-point energy solved ? Video. Part 2 coming soon, and you heard the story first, what happened, what's happening now, and how our research is kind of pivoted in a good way. So
Yeah. So
That's awesome, Ben.
yeah.
I'm not into rodent, but I get it. I like your work.
No, dude, it's cool that you got so much progress out of those videos. That's what's
yeah.
cool.
Well, Gerald, it's kind of suspicious to me, and I don't want to imply anything, but it is kind of suspicious to me how we don't see or hear from Randy Powell. We don't see or hear from Daniel Nunes. We don't see or hear from any of the people, Roland, Justine, who replicated Daniel Nunes' research with the coils, Jeremy, who he got the research from. The only person we still hear from is Marco Rodin. And I think that's a little suspicious.
Yeah, you could say that.
Probably a lot more to it. Yeah.
Yeah, there's probably more to it. Maybe I'm wrong. Who knows? But in this field, you can never be too careful. So
I'm just happy you came across the right videos, Ben, and got things more in line, kind of what they're doing and rediscovering it for everybody else out there.
Yeah, because like you heard it yourself, he was not intending to take all his videos down. I don't think that was him. He would have never sold out unless he was threatened or something. So, but it doesn't matter. The research is there again. I put it out there again. Everybody's welcome to it. It's not something that we intend to keep secret or monetize. It's something that's available for the benefit of the human race. So
absolutely,
and that's the way we want it. We want to have like he said, we want to have those stepping stone videos so people can be introduced to these concepts and implement them in their own way.
Yeah,
very cool.
He was a different kind of guy.
So
my mama said, if you ain't got nothing nice to say, keep your damn mouth shut.
There was a question that came in about salt water and energy. And it is in the salt if it breaks down or not, or if it's consistent in there in crystalline form, or if it's in its salinity. So it really kind of depends on the way you look at it. And everybody knows that if you have a crystalline form, you got one side that has magnetism to it. Can you get a spin out of it? Can you get a small magnetic field out of it? I don't know. Maybe you can, maybe you can't. I do know this. No matter what you do in this earth, there's crystal everywhere. It literally grows everywhere. So in caverns, it could be making microwaves in there, or did it one time and it creates a crystalline form. And then now that has a magnetic frequency itself. This earth is filled with the crystal form. So just so we understand that there's a magnetic spin based on that, and it has a lot to do with the energy there. So in salt water, do I expect to get more energy? Yeah, it's been proven that there is. So it's better than regular water.
I agree.
But I think it comes down to something like that you'd have to look into. One thing I will tell you is that if you do a conductivity test in water, it'll show zero conductivity. Now,
salt or just regular water?
Just regular water.
Oh, yeah, okay.
But if you add salt, you can get conductivity out of it.
Yep.
But I can get 10 times the conductivity out of it with a piece of granite.
Yeah.
So the granite has compressed quartz in it. So when you start looking at that factor, you're pushing upon the sides of the quartz itself, and now you have something more there than you did before. And one thing about quartz, just so you know, put it in a bowl, put a wire between the bowl, put 5 bowls, and put your anode and cathode there from your meter. And what you'll find is the conductivity level rises over time. And it'll continue to rise until you interrupt that circuit in some way. So that's just with the granite in there. You have a compressed granite, which is activating the quartz in the water. Not salt water, just regular water. Can you add to that? Yeah, fluoride. Add some
With the
fluoride in there, like you can get in rainwater. Like get it in your toothpaste, and it'll help the activation process in each one of them.
Oh, I recently found out one of the reasons why certain members of the scientific community will never take us seriously because we talk about the pyramids. Apparently, Bob Grenier is not taken seriously because he brings up the correlation between sacred geometry and the pyramids. I don't know. I would have thought that that's one of the key things that everyone was looking to try and find out. But I guess if you're part of a system that's constantly promoting the wrong people in power, then I'm gathering that you're probably one of those people that loves to take power away from those that, you know, deserve it, so to speak. I'm trying to be very vague, right?
Oh, you are. You're getting there.
Yeah. Yeah, sorry. Just I'm going off on a tangent. I'm ranting. Yeah. But yeah, so I don't know. I like pyramids. I love pyramids. I've always wanted to find the secret. Now I believe we have it.
It's one of the oldest mysteries in the entire world. You know, it's hypnotic.
Only a mystery though, because they won't let us.
It draws you in.
Go and poke around and investigate. They got it so locked down, it's insane, right?
Oh yeah, they kicked out Graham Hancock for challenging the mainstream consensus on the idea. Exactly, it's ridiculous.
Right? Mainstream, give me a break. It's like at the academia. Yeah.
It's like anything else, again. You know.
Okay,
like
guys.
Chainsaw, don't get me started. I'm just kidding.
Hold on, I want to show you. I was talking about this earlier, so I just want to share it real quick.
Oh, that's cool.
Yeah, actually, when you had said that, I went to his channel and I was checking it out. Nice. Gotta love that.
I wonder if he's got liquid in there.
I don't know.
Agent Fine Wine.
Just ask him.
Yeah, he's in the chat right now. Ask him.
Nice job, by the way.
Yeah.
Yeah,
that's so cool. Yeah.
In case anybody's wondering, it's this gentleman's name right here. Go check out his channel. Check out his work. He has 84 subscribers. Let's try and bring it up to at least 200. Come on, everybody. Go there and subscribe. He's doing good work.
Well, that's just...
way to go, Coils.
Nice. Yeah, I know. I don't want to pronounce his name in case I say it wrong. I don't want to insult him.
I tried it the other day because he was in chat the other day, and it was a disaster, and I almost cut it out of the video.
Yeah. He said the bottle's empty, though. But
yeah, so
that's why I didn't mention his name.
Is he trying to say negative resistance coil in abbreviation?
I think
Maybe.
So. I think so. I don't know, but I
think
right on that. He could tell.
Yeah, but we're not trying to say it any other way. Let me just.
Nope, because I don't know.
Well, staying out of that.
Yeah.
This is his page right here, guys. Go on over and subscribe to him. He's got a lot of cool stuff, and he does new videos every day. So
nice.
Totally awesome.
And his name is Chris. Thank you, Chris. So everybody go subscribe to Chris. That's his channel name. Awesome.
Yeah, look at just throwing everything at the fan, right?
Darn straight. That's the way you find things out. See what sticks.
Look at how bright those bulbs are, too.
Yeah. Hey, I got somebody even emailed me or sent a chat to me about potentially making a coil out of a football shape. You know, you never know.
Yeah. Why
Interesting.
Yeah, right?
Never thought of that.
I didn't either. You know, it was brought up as a suggestion, and I'm like, let me write that down in my notebook just in case, you know.
Don't tell that to Gerald. We'll never get a presentation out of him. You'll start building it. You'll be waiting another year.
I'm not making any new coils. I'm not building anything new until I've completed these last projects. Because
I would.
What's
I would
that?
actually love if you put all the new experimenting to the side and finish your whole thing on your
That's what I've been
presentation.
doing. I'm finishing up on my last stuff. I haven't done anything new. So you guys have a chance to get ahead of me. Go for it.
Oh, it's
That's
not that,
awesome. Is
Gerald.
that a
No,
cat
no.
bank?
No,
Is that a
I'm
cat bank over
encouraging
there in
it.
the
That's
corner?
what I'm saying. Like, what's that, Ben?
I'm sorry. Go ahead, Ben. I will put it back up.
I
Cat
was just
Bank, yes,
asking
he does have one.
Yeah, okay. I was just wondering because that
Oh.
capacitors look different sometimes.
I don't know.
Those are
I
fat
don't know,
boys.
Nathan. I may have to start again. Chris is giving me a run for my money. He has more than 100 coils.
Oh, okay.
I'm gonna have to get going. I don't know.
No, don't you dare. Don't you
Come on.
even dare.
What do you
No.
mean? I got another 20 to go, and I hit my 200 mark.
Gerald, I'm going to play that video if you keep going.
Okay. I'll get her done.
We're holding back a big secret, and I want Gerald to come out with his first because he deserves it. And I'm being nice and
I won't grind and make you wait any longer. We'll get her done right away. Okay.
Thank you.
All right. And then I'm building more coils.
Oh, yeah.
Chris is probably laughing. Yeah, that's awesome.
Oh man, always. So check it out. I'll give this people a little bit of a preview of what I was doing outside, just so everybody knows. But I won't show the actual experiment. I'll just show you a little bit. So this is my little lake or pond out there, and you can see the light in it. And we're just lighting up the pond a little bit, having a little fun there, trying to see if it radiates, and it didn't radiate. You can see the other lights aren't on. But I could stick these things right into the water and have them turn on. The cool thing was it was so cold out, I could take a light that was on and turn on another one further away because I added heat to the system. That's how I knew I wasn't double grounding it correctly. So the other problem I had is that every time I walked around, I didn't realize where the camera was, and I gave you a full moon shot throughout the entire video. So I cannot.
So hard. And not only does he do that, okay, everybody, just so you understand, he gives a full moon shot, and then he literally puts like this big cloud over his back going, full moon, be careful. It's awesome. I laughed so hard. And then Mike.
Oh,
that's just great.
Well, it's so funny because I cut the video, right? And I only put in the parts where the moon was showing, so it would be even funnier in the short version. But in the long version, didn't have that. But it's kind of one of the experiments that we're running outside. This is 10 feet by 10 feet, and it's getting there.
Yeah.
And I think honestly, I need some sand in the whole thing to do what I wanted to do.
I think you need height.
The height.
Yeah, I think that's the key in that one, because I was watching your drop off from full bulb, and then it went to like 3/4 and then gone. So that tells me that you have that peak, and then it comes down and then it cuts off, right? So if you had a higher point, again, like a pyramid, then it would push it up and you would have a further ground ratio to play with.
So let me ask you this. Should I go out and get some copper rods and make a pyramid shape in it?
Interesting. I never considered that. Honestly, my thought process was to just put your Tesla coil on a higher stand.
Well, the funny thing is, you can see where I put it. I put it on the bottom right there, right next to the ground. Usually, I have it on top normally when I do my experiments.
What do you think worked better? Did you try it?
Oh, put it on top.
And it works better?
Yeah, but how do I say this? It works better. It just makes it an issue when you get into the rod to the ground. So
yeah, I see what you're saying.
Yeah, it's not a problem to do some of it. It's just a matter of just figuring out how I want to set it up, and then we're good.
Yeah. Yeah, I know what you mean. Try using a longer brass rod. Maybe, I don't know. It's a thought, right? Maybe that'll do it.
Yeah, by the way, one of the secrets, and I'll remove this real quick, the rod going through the testicle has to be small. Once you get past that, you can go to whatever size you want. So if you wanted to tap something into the ground, you could do that, and you could just attach the rod to it, but the rod in the testicle has to be small.
That makes so much sense.
You can't use a fat rod in there. So I can't even say that on air.
I can go so many places with that. Get myself into trouble. Go ahead. But I'm small.
Wow.
Horrible I am. I'm sorry, guys.
That's why the wire was so much better. But the rod that I picked was really small and really thin, so it worked out perfect. I wouldn't go any bigger than that.
Right? From the rod.
Well, it doesn't change it. Look, it's not the rod that goes in there that you have to worry about that changes the frequency in your testicle when you want to do it. It's the mass that you attach to it.
Oh, okay.
So what I want to, I'll just show you something. Hold on. Let me grab it real quick.
No, we weren't talking about fat rods. In the middle of testicles. Take some green.
That's things like that's a monster, yeah?
Yeah.
But check it out. Okay, so you take your testicle. This is the rod right here. It's very, very thin. It's smaller than the size of your pinky. Okay?
Yeah.
Like
a clothes hanger size.
Like about 5 millimeters wide. Something like that.
Okay. A little bigger than a clothes hanger.
Yeah, a quarter inch.
Yeah.
So that's it. And it goes right down the center of your Tesla coil here. So check this out. When you set up your Tesla coil on the bottom, where you put your wire placement here matters, right?
Yeah.
If I wanted to change the frequency of my Tesla coil, here's where it normally oscillates on this line.
Okay.
I would move it up. Then I would come over here to the wire at the top, and I would add mass to the side of it. Take a metal plate, connect it to this. Now I've changed how much winding is on my Tesla coil. But it doesn't just work in that way. It also works as a load. So it'll act as inductance and a load. So you have to watch how you do this. So it's not just one effect, you're getting two, because you're not attached to the wire here that's off to the side. That has nothing to do with what we're doing. Nothing at all. That's why it's important. So check it out. When I put it to the top right here, I can now pull 8 megahertz out of this coil that resonates at 300 kilohertz. If I attach it here, but what I attach here has a value of 300 kilohertz. Because of where I attach it in a resonance, I can change it. I could do it with a ZVS, which is basically unheard of with a ZVS, by the way. And I could do it with a Slayer exciter very easily. So I can manipulate this testicle in any way that I want to for any frequency that I want to. So if you said, okay, I want to get down to 432 hertz, just understand I have a Tesla coil that I ran at 20 hertz. So can I get to 432? It's just a matter of math. All I need to do is figure out the mass that I want to attach to it, where I want to place the wire attachment to that. Now I have exactly what I want. Put it in any frequency I want. Now, understand this. The actual tuning fork itself, only when it's really super close to something like this will it turn on. but the problem is you'll spark out next to a Tesla coil. What do you have to look for? When you take two tuning forks together, they have a box. The box creates sound. The sound moves the frequency from one to the next. So what do you got to do? It's the same thing. You have a tube and you have a bottom cap to your tube. Now you need to see it as how you move your sound.
Right.
It now operates like a speaker without a diaphragm.
So the box is just a speaker. So in other words, okay.
So
That
now
makes sense.
if you wanted to turn on your tuning fork, just take the end of your rod, put it on the tuning fork itself, and make sure you account for the size of it so you can account for the mass that you put in there. Turn it right on. That's it.
That's funny. That kind of goes along with, I don't know, maybe how they levitated stones in the time of when they were building the pyramids. I don't know, just a thought. Just saying.
Hey, Gerald, some people think I'm nuts, okay, on how to run this stuff, but I've already showed them the test. This is not new.
I personally
People think I'm nuts too, Nathan. Let's form a club. We'll call it the Fringe Think Tank.
Well, they say that genius and insanity is a very, very fine line in between the two, right? So I prefer to think I'm just some dumb guy in my basement.
I mean, think about it. How many people have gotten a tuning fork to resonate with the Tesla coil? It's very few. Very few would not even know how to start to do it.
Nobody knows how to, change the frequency in a Tesla coil, let alone do what you're doing.
I had somebody tell me that my Slayer exciter pushed 10 feet at 20 volts. Let me tell you, with everything that I know about a Tesla coil, the most I've gotten out of it is 5 feet. And that, by the way, is like a record. When you can get 5 feet out of a Slayer exciter at 20 volts, that's a record. 10 feet would be a world record you'd never break. It has to do with my mud experiment. Somebody said that your Tesla coil field was going out 10 feet to where the light I put to the side of the mud was.
Yep.
And that was the entire thing. And just, dude, that's not even possible. It's not even conceivably possible. Even with all that I know, I can't do it.
10 feet's a long way.
Yeah.
Yeah.
I mean, Chris, I could push. Sorry, go ahead.
No. Go ahead. I'll answer that question when you're done.
I could push it 10 feet with a ZVS, but I would have to be around 60 to 70 volts going in DC. And I would have to cap both ends and probably fry my Tesla coil doing it. I would create so much. I'd have to create so much heat in the inside of my Tesla coil in order to push out that magnetic field, because the heat converts into amps. The amps converts into field distance. So I would have to literally heat the inside of my Tesla coil to a level that would be just unreal in order to push that far. But I could probably do it that way with the ZVS. But man, I'm going to have me some sparks of flying when it fails.
Kind of like that rip up the inside of the coil you showed on that video earlier.
Oh my God, dude. It's deep.
Tore right through it, looks like.
Oh, it did.
Yeah. I hate to say it because I know you put a lot of work into that, but that rip, it's pretty. It shows so much power, you know what I mean? Like, I love the freaking thing. I looked at it and went, oh, that'd be like a trophy to me. I'm putting that on my shelf. Lights on it.
I had to leave it outside for 2 days because it stunk so bad. Nothing but melted wire.
Yeah. That's the PVC that's melting, eh?
Yeah.
Yeah.
Oh, it didn't just melt it ate it.
Yep.
The wire coating went on it, and it literally ate the entire thing of PVC.
Yeah,
it was
right
gone.
through it, I'm sure. Right?
Yeah, but that's what I'm saying.
Yeah.
It tore it right out like it was nothing. Like a lightning bolt hit it.
That's what it looked like. Even the pattern of the burn was fractal.
Yeah.
Yeah. Well, hey, they say that Tesla played with lightning, right?
Well, here's the thing. I'm going to clean it up, and then I'm going to try to epoxy it. And I just need to see if the windings themselves are burnt or if it's just the casing. I just want to know for my own thing because it's basically a trophy sitting on my mantle unless I can get some use out of it. So might as well.
I would too. Damn straight I would. I'd use it as a teaching display, so to speak, right?
Hmm?
It shows how much power's in the middle.
Yeah. All right.
Yep.
You had a question you wanted to answer.
Oh, Chris had just brought up an old system that had come out. Let's see. I gotta find the comment again. Here it is. It's the Campanese buried a copper radiator years ago when the internet just started. Yeah, that was in 2008, I believe, that he did that video. I have that video on an old hard drive. You're right. I haven't seen it since either. This group of guys, they built something called a Campanese, right? It's basically like an amped up Tesla coil. It's got extra winding on it. I think there's 3. Could be wrong. Correct me if I'm wrong. But he had like a bunch of lights running. I think it was something like a 10 100-watt light bulbs fully running from 112-volt battery. And I believe it was because of the ground. Because he had this radiator buried in the ground, and the minute he attached the ground, that's when the lights were like super bright. So it's I believe that what Chris is talking about is the same thing that we've discovered, is that ground power.
Yeah, there's another guy out there who's doing this. I'll show you real quick.
Yeah,
And that's
actually,
what he calls it. He calls it a Campanese thing.
Oh yeah, I got subscribed to this guy. This guy's good. I don't remember his name, but I remember that video.
Yeah, it's why I want to add the battery pack right there to my Tesla coil.
See, the guy had lights running plus 1,000-watt kettle. That's crazy, all from a Campanese, which is, again, like I said, an amped up Tesla coil.
Yeah,
I can't wait till I see you take a 1,000-watt bulb, put it into the ground, and it turns on. That would be something to see. Okay,
real quick, I know we're getting towards the end. I just want to show something. We have somebody coming on next Monday.
Oh, yeah.
And if I can get to my history real quick, I'll pull it up. This right here.
Oh, yeah. The Thane Hein replica.
Yeah.
Yeah.
Ooh,
So he's gonna.
big.
Oh, you're getting this guy on next Monday?
Yeah, that's what I was trying to tell you. Ben, can you read his name real quick? Because I'm bad at names.
I can't see it from.
It's Heliarc.
Oh, yeah. Heleric, I think it is.
Yeah.
Oh, sorry. Can you hear me?
No, go ahead.
Oh, Heliarc or Heliarc, something like that.
Yeah, there you go.
There you go.
That sounds a little more appropriate to the name.
So he's going to come on and talk about all of his electrical experiments, and he's got a lot of them.
Awesome.
So it's really cool, man. I'm excited to talk to him. He's also, Gerald, he's also a prepper.
Nice.
Okay. Oh, it gets better for you. Okay.
Yeah.
So hold on. Let's go back here. Let's go onto his channel.
I'm not a prepper. I just like to be prepared.
You like to surround yourself with people who are prepared.
There you go. That way I don't have to be prepared. No.
Only Gerald.
Never.
Okay.
I like
Gotta
to
have
surround
fun, man.
myself with
Life's
people who are organized so I
short.
can pretend that I'm organized.
Yeah, I got buckets and buckets of air. So hey.
So I'm going to share this right here with everybody. This is his site. So go on and subscribe to him.
Yeah.
He also gets into the pole shift, Gerald.
Yeah, I know. I watched that video, and yeah, I know it's coming. I don't want to admit it, but it is.
So next Monday, we're going to talk a little bit of pole shift. He has some stuff that he can share and can't on his research.
Good.
Then we're also going to talk about all of his electrical experiments that he did on his channel.
Yeah.
So I'm truly excited, man. This is absolutely awesome. It's just.
I wonder, should I talk? Go ahead.
Do you go ahead?
I wonder if I should talk about the vision I had when I was 12 years old about the pole shift.
I want you to talk about it when he's on next week.
Absolutely, I will. And I've shared that on other channels in my testimony, so to speak. And yeah, it's known. And a lot of it has come true thus far. Hopefully.
Well, there's also an Indian legend about it.
Really? Oh yeah, the Hopi Indians. Yeah. I that part I'm gonna stay away from for now, because there's apparently that legend is well known, and I don't want to. You know what I mean? Because I told you about. Yeah. Anyway. Yeah. Sorry.
No, it's all fine. I just want to make sure everybody knows that's what we're doing on next Monday. So it should be a really awesome show. I'm looking forward to it a lot. So
It'll be
anyway.
I'm interested in it for sure. I look forward to it.
Yeah, it's gonna be awesome.
Yeah, just that whole replication that he's got going on with those coils, and then when you watch his videos and what he does from one to the next, you probably got a million questions by the time he's done.
Oh yeah, and his Thane Hein replica, he did good on that too. I was like, yeah, right on. So it'll be good to talk. Yeah, just like we love getting new people on here. So the more you like to experiment and you like to share, contact Nathan. We'll see what we can do. Right? Am I wrong?
No, you're right. Absolutely.
Yeah.
So I wanted to wait for a few more videos for Chris, and then I want to have him on and we'll talk to him, because he's got some cool stuff going on too. Yeah, with that wine bottle, and then he's got other experiments. I just want to make sure his channel gets up a little bigger, a little bit more stuff, and then we'll have a ton to go over and talk about. So
yeah, we'll try and get those subscriptions. We'll get those subscribers pumped up for you there, Chris. At least the best we can. We got to get people over to your channel. So yeah, for sure.
Yeah. So that's what we have going on for next Monday. Wednesday, I'm gonna go ahead and go over the cold energy circuit again, and I'm gonna have Gerald help me out with it. I'm gonna show the video that I made. Gerald's gonna talk about it. We'll go over that. Ben's probably got another circuit to bring out, right, Ben? You guys have more work that you're doing on that?
So we don't have a new circuit at the moment, but I could explain further the changes that I made to the current circuit. So it's a pretty simple change, but I can show you that on Wednesday.
Nice. I know you're doing testing still, so that'll probably work out good. And then I know Sean always has a presentation on Wednesdays. So
and I should, unless something gets seriously in the way tomorrow, I should be done with the experimentation on the globe, and I'll be able to show it. So I like mapping these coils before I show them, because if I get questions and I don't have the answer to it, it's, you know what I mean? It just bugs me. I'm anal that way, anal retentive in that motion.
No. You're messing with another coil before your presentation, Gerald.
Okay, but I can't talk about my presentation because there's those out there that don't want to hear it.
I don't care. I want to hear it.
That's fair. That's fair.
I want an hour long of just Gerald talking about his coil in theory and everything else.
An hour? Oh, man.
You could do a little less, but I'm just saying.
I had it trimmed down to 5.2 minutes. I was good. Now I got to go an hour? I'm kidding. I'm seriously
I don't think
kidding.
so. No. He's the master of explanation. When he tells you, just run it in reverse.
It's awesome. Here's the coil. Run in reverse. Have a good day. Isn't that the way it's supposed to be done? I mean,
no.
People, I'm totally kidding. Yeah.
Master of explanation here.
This time it'll be a little better. I put some work into this one.
Yeah, well,
in the anime, I kind of snagged from a lot of different people, but I did reach out and ask people for permission. Not everybody got back to me, but not everybody said no either. So I'm gonna do it, and if they ask me to take it down, well, whatever. At least the presentation's done, and if I have to, I'll fix up some of the editing. But yeah, we're there.
All right. Before you start other experiments.
All right.
He doesn't care. He's gonna do what he's gonna do.
All right. Oh, got her.
Ian's on you now.
Oh, okay, there.
He's gonna run and play.
Trouble.
Waiting for Gerald.
I'm getting yelled at from around the world now.
That's right. We all have constipation here, Gerald. We need to let it out. Holding it up.
Of the nation's anticipation of Gerald's presentation.
I got a painful bubble gut. It's hurting.
Yeah. We'll get her done. I won't say when. I'll just say we'll get her done. Because when I say when, people show up and it's all great, but then the ones that we don't want showing up with my computer, and then it all goes sideways. So let's not.
I'll be honest with you, Gerald. We're at the point where I don't care who shows up. I really don't.
No, I hear you. I'm doing it for the people in the comment section and whoever else decides to show up. But it's basically for you guys and just the crew that wants to know. Anyone else? Well, tip of the hat. Have a nice day. What am I supposed to say, right?
We had someone mention that we were not very good at showing our work. So I wanted to make sure that we shove it right in their face, that we're showing our work. So
not a problem. Not a problem.
You understand what I mean?
Uh-huh.
I have no problem showing my work. I show it all the time, and I show you exact experiments.
See, you know what it is? Oh, go ahead.
No, you go ahead.
Well, I was going to say, you know what it is? People that complain that we don't show our work are usually the people that aren't doing the work themselves. And they just want to beak off because, I don't know, call it whatever you want. They don't want to do the work, or they're too lazy. They don't have the aptitude, or it's just not in them, whatever that reason may be. But to denounce somebody's work because they don't show exactly what it is that you want to see isn't very professional. I mean, not that I'm very professional, but you know what I mean, right? Like, I've heard a few people complaining about how I should really do more theory and math, like what you've been telling me, right? You're absolutely right. So I'll get her done.
Okay, hold on. Did somebody take out comments from Wizard or Winzard?
I never.
Winzard. Yeah, he said something derogatory, so I took his comment out and I put him in timeout.
Okay. All right.
Ben, you're going in timeout too, Ben. Takes two to tango.
Hey, I'm always in timeout. I'm used to it, okay?
Get in the corner. No. I'm kidding.
I just want to make sure it wasn't a glitch in the system. I'm sure you had your reasons.
No, I'll explain after stream.
Okay.
That's cool.
Good enough for me. All right, guys, that's all that's going on. Thank you very much for showing up, guys. I hope you guys all had a fun time. We'll be here on Wednesday at 3 o'clock. And it's going to be a fun week. Anybody got anything else?
See you Wednesday.
Yep. See you Wednesday.
All right, guys. Have a great night. Thank you very much.
Thanks, everybody.